So let us start the third topic in this unit, that is normal distribution. So this normal distribution is extensively used in our daily life here. So if you see that contents in this, here we have to see the introduction part of this normal distribution, applications, standard normal distribution, characteristics and problems on this. So if you go to the introduction part here, this normal distribution is very important in almost every field of our daily life here. Not only in the business field but also in the technical field here. So whatever the sample we consider, so for that sample the entire sample theory is based on the normal distribution. To test any sample here, ultimately we go for the normal distribution. So this normal distribution has come from the random variable concept. So this is the only one continuous distribution which is defined from minus infinity to plus infinity here. And the rest of all continuous distributions are defined from 0 to infinity. So to find the average of any situation regarding the continuous random variable, we use the normal distribution. But for the discrete random variable, we consider the Poisson distribution here. But of course, if the number of trials are indefinitely large, right, then the binomial distribution tends to the Poisson distribution, and the probability of success is also very small, that means 0, it tends to the Poisson distribution here. But when we need to find the range between the average of that experiment here, we have to move on to the normal distribution. That means the binomial distribution also tends to the normal distribution. So mathematically this distribution is also known as the Gaussian distribution. The other name for this normal distribution is Gaussian distribution. So in the technical field it is also mostly known as a Gaussian distribution. Now if we come to the application part here you can see the number of persons in that, right? So if I want to know the average height of a particular locality people, right? So these people are residing in particular locality. So I want to know the average height of that particular locality there. So then here I can use this normal distribution. In general here the average height means the normal height of the human being is considered as some 5'4" to 5'6". Means 5'4" to 5'6", almost the 90% of the human beings will lie in that interval here. So for that we can consider this normal distribution application. The next part we can take is the IQ level. So IQ is common, the intelligence coefficient is common to every human being. But the thing here is that the way we utilize our IQ levels, right? So someone used to that maximum extent and someone just use it in a moderate level, and due to some physical defects in there, they will use it very low level here. So here if you see the graph here, IQ graph, right? So the central line is there, that is here 100 is given. So that means here 90% of the people use the IQ levels depending on their situations, right? So if you see regarding the placements drive, we can take the example here, right? Out of the 100 students, definitely here 30% of the students are very extraordinary here. So that comes under that part here, that is 145 in the graph you can see. And here if you observe in the 100 students, 10% are very dull, right? So that is the 55 here, right? And some students are in moderate, so that is here 100, right? So what is this 100, what is this 55 and what is this 145? Later we will discuss in the further slides here. And the one more application is here, if we can see naturally the birth weight of a newborn baby is in between 2.5 to 3.5, right? And there are very rare cases where a newborn baby is less than 2.5, and there are the cases where the newborn baby is more than 3.5 also. But in general, in the natural scenario, if you see here, the weight of a newborn baby is here in between 2.5 to 3.5. So this 2.5 to 3.5 is known as the range of that. Means it is the average weight of a baby we can consider here, right? Then if you see the probability density function of a normal distribution, it is given by 1 by sigma into square root of 2 pi. Even that sigma you can carry into the square root also. Then it becomes 1 by square root of sigma square into 2 pi. Right? So you can write it either out of the square root or inside the square root. If you want to write it outside the square root here, it is 1 by sigma. So 1 by sigma square root of 2 pi into e power. So this e power, e term is there in the numerator here. e power minus 1 by 2 into x minus mu by sigma whole square. Now what is this x here? X is a continuous random variable which takes the values from minus infinity to plus infinity. There I have mentioned the condition also. And here mu is known as the mean of the normal distribution, and sigma is known as the standard deviation of the distribution here. So finally the parameters of normal distribution are mu and sigma square. Sigma square is the variance of the distribution here. If variance is sigma square, then ultimately standard deviation is square root of variance, that is sigma here. Right? So simply we can write the notation as x follows n of mu comma sigma square also. Then here, if here mu is equal to, means mu is 0 and the variance is equal to 1. When sometimes the mean of the distribution is 0 and variance is equal to 1 here, then the normal distribution becomes a standard normal distribution, which is also known as a normal variate. So it is given by here 1 by square root of 2 pi, sigma square is 1, means sigma is also equal to 1 here, because square root of 1 is 1 only. E power minus 1 by 2 into here x minus mu, means mu becomes 0, so x square by sigma is 1. So it is only, simply we can write it as 1 by square root of 2 pi e power minus x square by 2, or if you are defining the term in terms of z, so 1 by square root of 2 pi into e power minus z square by 2. So remember here x is taking the from 0 to infinity. When that is the case, then it has a bell-shaped curve like this. Okay, so in this bell-shaped curve it has also some characteristics, this normal distribution. So what are those characteristics we will discuss in the next slide here. So the first characteristic is here, it is a symmetric distribution. Symmetric distribution means when mean equal to median equal to mode, then that is called the symmetric here. And this normal distribution is a bell-shaped curve here. Right? So if you see this part is known as left tile, and the central line is your mean, median and mode, and that part is called as the right tile here. So left tile is defined for negative values and the right tile is defined for here positive values. So the characteristics are, it is a bell-shaped curve, it is a symmetric distribution since mean equal to median equal to mode, and it is always asymptotic on x-axis here. Right? And always depending on the mean only we can interpret the data here, and almost the sampling theory is based on normal distribution, I said before, right? So the sampling theory is also based on the mean of the sample only. Then the area of this entire normal curve is equal to 1, and it is defined from minus 3 to plus 3, the x-axis range here. So remember here area of the normal curve is equal to 1. So based on this normal curve only, we have to solve the problems on normal distribution. So to solve the problems on normal distribution, we have some tabular values also. So just I have kept the example for this. If the z value is equal to 1.28, right? So this vertical part here, it represents the 1.2, means after decimal first digit. But you have 1.28, then the topper part, it represents the second digit in the number here. So after decimal the second digit is there on the topper part here, and this vertical part is your z value. So only the integer and after decimal first digit will be there. So here I have rounded off that value also. Here if z equal to 1.28, so take here 1.2, and in 1.28 after decimal the second digit is 8, so they are 0.08, because if you add those two, 1.2 plus 0.08 is 1.28, so that is the value given there. So I have rounded off that particular value, that is 0.3997. So like that you have to consider the tabular values for solving the normal distribution problems. Now let us see one problem on this. So the mean and standard deviation of the marks obtained by 1000 students in an examination are respectively 34.5 and 16.5. So mean marks of 1000 students is 34.5 and the standard deviation of the marks is 16.5. Now what is this standard deviation of marks here? So if I consider a particular class here, in the particular class 50 students are there. So I want to know the average performance of that class in a particular subject. So I will consider the each individual marks of 50 students and I will make an average of that. But we are not sure that all the students have given their original marks whatever they are awarded, right? So due to some hesitation feeling or due to their less marks, right, and they want to show off, they have given a false marks here. So instead of here, out of 50, instead of 32, that some X has given the marks as 42, that means the 10 marks variation is there in their original marks. So the 10 marks variation is nothing but the deviation here. So definitely whatever may be the data, there may be a deviation in that, whatever the things you consider, right? So the deviation also we have to consider in every situation here. So assuming the normality of the distribution, find the approximate number of students expected to obtain marks between 30 and 60. So in binomial and Poisson distribution, just we used to find the probability of random variables when the probability of success and the probability of failure is given and the average rate of experiment is given. But when the mean and deviation are given and we have to find the range between the, means probability of the range between the variables, there we have to use a normal distribution here. So if you move to the solution part here, n represents the total number of students, that is 1000, mu equal to 34.5 and sigma equal to 16.5 here. Now find the means number of students expected to obtain between 30 and 60, means probability of 30 less than x less than 60 you have to find. So here first we will consider when x equal to 30. So our z is nothing but standard normal variate given by x minus mu by sigma. Now here 30 and 60 are known as the two random variables. So x1 equal to 30 and x2 equal to 60. Then z1 equal to x1 minus mu by sigma, that is 30 minus 34.5 by 16.5 is nothing but minus 0.2727. And when x2 that is 60, then z2 equal to x2 minus mu by sigma, that is 60 minus 34.5 by 16.5 is 1.5455. If you see here, z1 value is minus 0.2727 and z2 value is here 1.5455. So definitely the mean lies between the two random variables only. So z1 is negative, that means left tile, and z2 is positive, that is right tile here. Now we have some formulas for this to identify the table value also, right? So those formulas are nothing but if you want to find the probability of x1 less than x less than x2 and both z1 and z2 are positive, we have a separate formula. Both z1 and z2 are negative, the same formula of positive only. And if z1 is less than 0 and z2 is greater than 0, then we have a separate formula here, that is modulus of a of z1 plus a of z2. So using the tabular values here, okay, so here I have shown the curve also. So minus 0.2727 is left tile and 1.5465 is right tile here. So if you move on to the table values here, see that 0.2727, so 0.2 under 0.07 we have to take, because these standard normal tables are defined for only 2 digits after decimal, right? So it is here 0.1684. right? And similarly you consider the tabular value for 1.55. So that is, so if you see the 1.55, the tabular value is here 0.4354 like that. So we have to add these two values. So it is here 0.5458. So it is the probability of the students in between 30 to 60. But here they are asking the number of students. Total students are here 1000. So multiply that into 1000. It is here 546, because 545.8. So students means it should be an integer in a number. So approximately it is 546 students. So in this way we have to solve the normal distribution problems. Some more problems are there, we will discuss in the next class here. Now we have seen what is normal distribution, right? So we said that when mu equal to 0 and the variance is equal to 1, then the normal distribution becomes a standard normal distribution here. That is z equal to x minus mu by sigma. So here z is known as a standard normal variate. So when mu equal to 0 and sigma equal to 1. Sigma square is equal to 1 means here sigma is square root of 1 is also sigma is also 1 here. Right? Now if you see that normal distribution is a bell shaped curve, if we represent on a x-axis, right? So this is a bell shaped curve here. Right? So this is known as a left tilde and this is known as a right tilde here. And this line is nothing but here x equal to mu. Means this line represents the mean of the distribution here. So here it carries the negative values and this right tilde carries the positive values here. Now when we solve the problems, we come across the three cases here. So the first case is here probability of x1 less than x less than x2. Then we have to substitute this x1 and x2 in the standard normal variate. That is z1 equal to x1 minus mu by sigma and z2 equal to x2 minus mu by sigma. Now again here we have two cases here. The first one is that if z1 less than 0 and z2 greater than 0, right? Then probability of x1 less than x less than x2 is given. Here z1 is less than 0 and z2 is greater than 0. Means z1 and z2 are of opposite sign. Then it is given by a of z1 plus a of z2. Where a of z1 and a of z2 are obtained using standard normal table values here. And there is also a second case, that is both z1 and z2 are either less than 0 or greater than 0. Means both can be positive or both can be negative. Then in that case here, probability of x1 less than x less than x2 is given by modulus of a of z2 minus modulus of a of z1. Right? So you have to find the subtraction between these two and apply the modulus here. So in this case, we find the probability of between random variables. And also, we need to find the second case is that probability of x less than or equal to x1. In that case also, we have to find z1 equal to x1 minus mu by sigma. Now again here, two cases, that is z1 is less than 0. Here z1 is less than 0 and we are finding less than. So both are same symbol. Then probability of x less than or equal to x1 is given by the formula 0.5 minus a of z1. When here the easy way to remember the formula is when both are of same sign we use minus symbol, right? And the second case is here if z1 is greater than 0, right? Then probability of x less than or equal to x1 is given by 0.5 plus area of z1. That means here both are of opposite sign, here greater than and here less than. So it is plus here. So how it is plus and minus? The total area of this curve is equal to 1 here. If we want to find only here and this is less than that, right? Then it is only 0.5 minus this value. And if you are finding greater than, so the probability of this right tilde is 0.5. So it is also 0.5 minus. But when we are finding from the both range x1 less than x less than x2 here, then we have to consider the total ordinate of that. Right? And the third case is here, we have to find probability of x greater than x1 here. Then also we have to find z1, x1 minus mu by sigma. So first one, z1 is less than 0. So we are finding here greater than and here z1 is negative. Then probability of x greater than or equal to x1 is given by here opposite symbol are there. So plus area of z1. Okay, and the second case is here. The second case is here. Here z1 is greater than 0. So we are finding probability of x greater than or equal to x1. So it is given by 0.5 minus a of z1. So what are the things you have to remember by solving the problems is this one, probability of x1 less than x less than x2 when both z1 is less than 0 and z2 is greater than 0, it is given by a of z1 plus a of z2. When both are positive or both are negative, then the formula is here, probability of x1 less than x2 is modulus of a of z2 minus a of z1. When we have to find probability of x greater than or equal to x1, right? So here, if you see that here it is z1 is x1 minus mu by sigma, z1 is less than 0. So here the formula is 0.5 plus area of z1. And here z1 is greater than 0 and we are finding probability of x greater than x1. So it is 0.5 minus area of z1. Then if we are finding probability of x less than x1, here z1 is negative, so it is 0.5 minus area of z1. And if z1 is greater than 0 in this case, then it is 0.5 plus area of z1. So all the formulas in this rectangular box you have to remember to solve the problems of normal distribution.